Okay, now we are going to see orthographic projections in module 4. So the actual language of engineers starts from this module. So before we go into the details of orthographic projections, first let us know what is meant by a projection. Projection means obtaining an image of an object on a plane surface. So what is meant by a plane surface? You take this pad, this is a plane surface. So if you get the projection, suppose if you take this as an object, if you get the image of it on a plane surface, that is called the projection of the object. So to get an projection, you should have a plane. So let us see what are the various types of projections. See here, you can see there are three types of projections. One is orthographic projection, second is isometric projection, third is perspective projections. So we are going to see mainly in the coming modules orthographic projections, and also we will cover isometric projection, but perspective projections is not in our curriculum. Okay, so next you see this figure. There are two figures here. One is what you find in the cinema halls. So what do you find in the cinema hall? If you want to see a good movie, you should have a screen. Whatever may be the movie, unless there is a screen, you can't see the movie. So that screen is nothing but the plane surface or a plane on which you get the image of the object. Right? So you should have another thing important, a source, a projector where from the light rays come. You can see. So rays come from the projector, they touch the object and then they meet the screen. You get the projection. So in our engineering terminology, we call the rays as projectors, and this is AB is the object, and what you get on the screen is called the plane, and what you get on the screen, that is image, is called the projection. So from this figure, what is a projector, what is a plane, what is a projection, and what is an object, what is a source. This is what you find in the cinema halls. But in this orthographic projections, if you see at the other figure, see the difference. The projectors are parallel. That means the source is at infinite distance. They are not diverging rays. So the projectors are parallel, and another thing is they are perpendicular to the plane. And third, you can observe the projection and the object are having the same dimensions. And this type of projection is called the orthographic projection. So what is meant by an orthographic projection? Orthographic projection is a projection where the projection will have the same dimensions as that of the object. That is number one. Or the projectors are parallel and perpendicular to the plane. The projection you obtain is called the orthographic projection. So please, you see that is what meant by orthographic projection. So this is explained here. Now coming to any projection, see, suppose if you take this circle, if you project onto the plane, this is a two-dimensional one. This is a two-dimensional one. Even if you take a solid having three dimensions, if you project it, you get only 2 dimensions of it. You don't get the third dimension. So, if you take actual objects having 3 dimensions, one single projection will not give all the 3 dimensions. So, you have to go for 2 different projections, obtained by seeing from 2 different directions. So, for that, if you want to see 2 movies, you should have 2 different screens. You can't see 2 movies on a single screen. So, here also, if you want to have 2 different projections, you should have 2 different planes, and they are to be named differently. So, here you can see in the picture, there are 2 planes. One is horizontal plane parallel to the ground, another is a vertical plane perpendicular to that. So, these 2 planes are used to get 2 different projections. And by making use of these 2 planes, see, for example, I have made with this. You can also make using the greeting cards or wedding cards. So, I have taken 2 planes. One is horizontal, another is vertical plane. So, this is called horizontal plane, this is called vertical plane, and in a short way you call it HP and VP. So, by making use of these 2 planes, you can get 4 quadrants. You can get 4 quadrants. So, how do you number the quadrants? If you see this figure, you can see there are 2 different ways of numbering the quadrants, unlike in the mathematics where we always give first quadrant for positive x, positive y, like that. But here the numbering depends on the direction at which you see the planes. Suppose you are looking from the right side, then you have to number this as first quadrant and second, third, fourth. As you see at the figure, this one, you are seeing from the right side, thereby you are getting first, second, third, fourth, like this. But when you are seeing from the left side, then quadrant numbering will be first, second, third, fourth. So, the way in which you see, unless you indicate from which direction you are seeing, you cannot fix up the numbers. So, please bear it in mind. It is not always like in the mathematics, first is. So, it depends on the direction. So, how to define these quadrants? Here you can see first quadrant. If you take any object as in the first quadrant, means it is defined as above horizontal plane, before vertical plane. So, suppose you are seeing from here, this is first quadrant for you. So, if the object is located here, that means it is above horizontal plane and before or in front of the vertical plane. Similarly, this will be second, that means it is above horizontal plane and behind vertical plane, and third is below horizontal plane, behind vertical plane, and fourth is below horizontal plane, before vertical plane. So, whether you see in this direction or on the other direction, that is either from the right side or left side, first quadrant is always above HP and in front of VP. Similarly, second, third, fourth. And you can remember also this way. Always, suppose for me, the first quadrant and fourth quadrant are on my side, second and third are on the other side. So, first and fourth are before VP, second and third are behind VP. And another way of remembering is, first and second are above horizontal plane, third and fourth are below horizontal plane. Okay. So, projections, another. What is the name of the projection you obtain in the vertical plane? What is the projection name you obtain on the horizontal plane? If you see here, the projection obtained on the vertical plane is called as the front view or the elevation. So two different projections obtained on different planes must have different names. So the projection obtained on the vertical plane is called front view or elevation, and the projection obtained on the horizontal plane is called the top view or plan. So these are the names. How you name the two different projections obtained on two different planes. Okay. So having got these four quadrants, our drawing sheet is a single plane. If you want to represent any drawing, that is two different projections of an object on the drawing sheet, you cannot have vertical plane, horizontal plane. Our drawing sheet is on a single plane. So for that, you see this mechanism, how these two planes are made as a single plane. This is a horizontal plane, this is a vertical plane, and when you are seeing from that side, from your side, this is first quadrant, and this is second, third, fourth. So always remember, and the line of intersection of these two planes is called reference line, and it is named by XY. So the two planes intersect along a line just like two walls intersect along a straight line. So this is a common line. Reference line is called line of intersection, represented by XY. So you get the front view on the vertical plane by seeing from the front, and when you see from the top, you get the projection on the horizontal plane. So these two projections on two different planes, to draw on the drawing sheet, you should rotate this horizontal plane always such that first quadrant 90 degrees becomes 180 degrees. So this direction of rotation of the horizontal plane is always same irrespective of the object, whether it is in the second, third or fourth quadrants. So accordingly, as the plane rotates, the projection on that also rotates. So first these figures will tell you how to rotate the plane, and ultimately horizontal plane comes and coincides with the vertical plane. But the XY line separates the two planes. Above XY line represents vertical plane, below XY line represents horizontal plane. So this is very important to remember. Let us see, take an object. I have taken an object as shown here, the three-dimensional object having a length, having a height, breadth and thickness. Suppose if you assume this as in the first quadrant, and when you are seeing in this direction, you are getting the image on the vertical plane like this. And when you are seeing from the top, you are getting the top view on the horizontal plane. So when after you rotate horizontal plane and make it coincide with vertical plane, you see here as shown in the other figure, top view and front view. This is the front view, this is the top view. If you observe, the front view gives only two dimensions, that is breadth and height, whereas top view gives breadth and thickness. So from this, what do we conclude? If the object is in the first quadrant, you get the front view above XY, as above XY represents vertical plane, and below XY you get the top view, as below XY represents horizontal plane. And the projections, please see this, projections thus obtained when the object is assumed as in the first quadrant is called the first angle projection. See, please remember, all the topics or modules we are going to apply first angle projection. This is the Indian ISO code. As per ISO code, we have to adopt only first angle projection. But to start with, for learning we use for projections of points all the 4 quadrants. Subsequently, we use only first angle projection, means we assume the object as in the first quadrant. Now let us see second quadrant. Same object is assumed as in the second quadrant, and you see the front view coming on the vertical plane, top view coming on the horizontal plane, and due to rotation of the horizontal plane, it goes upwards. Thereby, top view also goes upwards. Now you can see here in this figure, both projections coming above xy. So please remember, if the object is in the second quadrant, both projections come above xy. So this is the observation from this. Coming to third quadrant, object is below HP, behind VP, and you are getting top view on the horizontal plane, front view on the vertical plane, and due to rotation of the horizontal plane, the top view goes up. So you can see here in the top view coming above xy and front view coming below xy. So it is just opposite of the first quadrant, if you observe. So what is the conclusion? When the object is in the third quadrant, the top view comes above xy and the front view below xy as shown. And fourth quadrant, it is below HP and before VP. Object is below HP and before VP, and when you see from the top, you get horizontal, top view on the horizontal plane and front view on the vertical plane, and due to rotation of the horizontal plane, the top view comes and coincides with the vertical plane, that is with the front view. With the result, you get both the projections below xy, both top view, front view. So this is you have to remember, when the object is in the fourth quadrant, both views come below xy, both VP and HP come below xy. So ISI Code of Practice, Indian Standard Institution, recommends the use of first angle projection method. Therefore, first angle projection means the object is assumed as in the first quadrant, hence the front view comes above the xy, top view below xy. This is adopted in all the other modules. So this is the summary of the different quadrants and their projections with respect to xy. So it's just to remember, one should be thorough with these definition of the quadrants and how you get the projections with respect to xy above or below. So one should be thorough. And I have given some exercise, the multiple choice here, and then you can answer this to know whether you have understood the subject or not. Okay, so now let us now start. As I told you, this is the language of engineers. Any language you have to start from alphabets. One cannot become an English faculty without learning alphabets. So here also we learn this language, that is projection of objects. So objects are different types, having no dimensions at all. Dimensionless object is nothing but a point. So we start with projections of points, and then we take up one-dimensional object, that is a straight line. And third, we take up planes, which is a two-dimensional one. Then finally we come to solids, which are three-dimensional. Therefore, we have to learn the projections step by step. We cannot jump like any other language. So let us now learn how to get the projections of points. What is a point? Point is a dimensionless object, but it can be assumed in the space at some distances from the reference planes, that is HP and VP. And also you can assume the point as in the first quadrant or in the second quadrant or third quadrant or fourth quadrant. But how to represent the projections of a point? Always we name the points by capital letters A, B, C or X, Y, Z. So capital letters indicate the actual point and then their projections. Small letters, that is A, small b, small c, indicate the top views, and front view is indicated by adding dash, that is A dash, B dash, C dash as shown. So this is a universal. Language is always a universal, not pertain to particular college or city or state. Universal language. English is English. So we cannot have one type of English and some other place we can't have different. So here small letters A, B, C, D, etc. indicate the top views of the respective points, capital A, B, C, and A dash, B dash, C dash indicate the front views. So if you simply indicate it by A dash, means it represents the front view. You need not write front view. If you simply write A, small a, it represents the top view. So this is the understanding. Now let us take a point, capital A. Name of the point I am taking it as capital A, as assumed as in the first quadrant, and I have taken the distances 4 centimeters above the HP, 3 centimeters before the VP. So that means it is in the first quadrant. So this is what you have to imagine. Just for you to understand, I have given you this figure. So when you read the problem, you have to imagine that point in your mind. So A is located at 4 centimeters, or that means 40 mm above HP and 30 mm before the VP. So when you are seeing from the front, you get its projection on the vertical plane. This is the front view, that is A dash. And when you are seeing from the top, you get its shadow on the horizontal plane, that is the top view. So when you are rotating it, horizontal plane, when you are rotating, it comes along with that here. So ultimately you will get above XY A dash, below XY A, and this is how you have to represent on the drawing sheet, not this figure. This is just for you to understand. But if you want to draw on the drawing sheet, the projection of the point A is represented like this. So first you draw XY, then you take a point, then draw one perpendicular, and from the point on XY, you mark 40 mm above, you get A dash, and mark below 30 mm, you will get point A, that is top view. And you have to indicate the names, dimensions, everything like this. So this is the projection of a point in the first quadrant. Suppose let us take, so these are the important points you have to observe from this. What distance you are getting in the front view, what distance you are getting in that top view. So distance you get in the front view is the distance above HP, and the distance before VP you get in the top view. Okay, next let us take point B in the second quadrant. That means point is, name is B, capital B, 4 centimeters above the HP, 3 centimeters behind the VP. So this is how you have to imagine the point, and as because of rotation of the horizontal plane, the top view also comes above XY. As we have seen earlier, if the object is in the second quadrant, both projections come above XY. But what are the distances? The front view is at 40 mm, top view is at 30 mm. So please you have to remember this, and one for the other if you should not mark. So which is B dash, which is B, you have to be careful, and only properly you have to mark. So benefit of doubt, you should not leave it to the teacher. So these are the observations from the second quadrant. Now let us take a third case, that is a point C in the third quadrant with the same distances, 40 centimeters above HP, 40 mm and 30 mm behind VP. And you can see this figure as in the third quadrant, and you will get top view here, front view here, and when you rotate horizontal plane, top view goes above and front view will be below. So the distances 40 mm in the front view, 30 mm in the top view. So please see what distances are coming and what projections are above XY or below XY. Next, last, fourth case, a point D is taken in the fourth quadrant with the same distances. It is below HP, before VP. So as because of rotation of the horizontal plane, both are coming below XY line, and name them as D and D dash. D dash is at 40 mm and D is at 30 mm below. So yeah, this is to be imagined, and you have to draw like this. So these are the observations from the fourth quadrant. So here all the four different cases are shown on a common XY line. What is this? See, if you observe this figure A in this, there are three ABC figures. In the figure A, all the four cases, if you observe, all the front views are on XY. That means the height that is above HP or below HP is made 0. So what does it mean? If the point is above HP by 0 millimeters, means it is nothing but on the HP. Okay, so a point on HP means its front view comes on XY. So this is the case. A dash, B dash, C dash, D dash are all are on the XY line. So when do you get front view on the XY line? When the point is on the horizontal plane. That is, height is 0, below or above. Coming, if you look at the B, all the top views A, B, C, D are on XY. Top view means it is seeing obtained from the top. Suppose if the point is on the VP, that is before or behind is 0. If a point is on VP, its top view comes on XY. So here all the A, B, C, D are on XY. So if a point is on VP, its top view will come on XY. So coming to this one, both front views and top views are on XY. That means their distances from the reference planes are zeros. Both distance from HP, distance from VP, both are zeros. In that case, both will come on the XY. So these three cases we have to remember. One of the distances are zeros. Here both are zeros. Then you get projections on the XY. So this is explained here in this. Now there is another important point, shortest distance of the point from the reference line. So shortest means, so people think whichever is lesser. See here 40 mm above HP, 30 mm before VP. People think 30 mm is the shorter, but it is not so. If you see this figure, shortest distance from XY, that is the what it means. So this is the given point. It is having 40 mm above HP, 30 mm before VP. But what is the distance of P from XY? You join it like this. So this is nothing but a hypotenuse. So square of the 4 plus square of the 3 taken square root will give the distance, that is 5 centimeters or 50 mm is the shortest distance from the XY line. It is not whichever is the smaller from among the two distances. So this is sometimes. So these are the general conclusions from what we have seen so far, right? So if you remember these points, this will make easy for to understand the another second module, the other module. And I have given some problems for you to practice. I have given the different points at different distances, so you have to draw the projections, right? And here I have given the projections, and from this you must write what is the distance of the point A from HP, from VP, B at how much distance from HP, is it above or below, or is it before or behind. We have to describe the point from the projections given. So you can practice these problems. So unless you are thorough with these projections of points, the other module on projections of straight lines, one cannot understand. This is a language. You cannot understand without knowing alphabets, the words, next sentences. So you cannot jump, and you have to learn one by one. So these are the problems. Okay, that completes the projections of points. Thank you.